Okay, you can see the slide now. Blank slide.
And Doctor.
Okay, good. Okay. Right. So it's moving right now. Okay. So let me recap. Okay. For example, to get a very nice rate of drawing curve graph. So from the fluid moisture content versus time here. So you have to select a few points, right? So you need to select it, all right? From that point, then you draw a tangent line. So that tangent line is supposed to be on that point, okay? So let's say I want to change the color here. Right, let's say you just select a few points here, 1 point here, to get the dx over dt here, the tangent. And maybe you select another point here, so dx over dt here. And maybe you want to select 1 point here, so you get dx over dt. So maybe you skip one and then you take this one, so you have dx over dt. And another one here, dx over dt. So make sure that this tangent is specifically only for 1 point. So it's not, because some of you, okay, if you have like something like plot like here, like this, what you did is basically to get the dx over dt, you plot one line. So that line is crossing 2 points, something like this. So that is, you thought that this is the dx over dt. So this is not. This is the wrong method. It's supposed only 1 point here, and then you make the tangent. So that tangent is referring to that particular point only. And to ensure that you get a nice r versus x, so dx over dt, the value is supposed to be decreasing. For example, here if you calculate 0.8, so here could be 0.5, here could be 0.3, and the value is decreasing. Then finally, when you plot here, you're going to get, okay, 1 is going to be constant, and then you're going to get like a falling, something like this, okay? Because some of you, when their dx over dt, some points is going up and going down, so they're going to obtain a graph of r versus x, something like this. Constant is constant, but when in the falling, they get like this. So they have a few points that suddenly going up. This is because of your dx over dt is higher than the previous point. All right, so avoid that mistake so that you're going to have like a smooth r versus x, something like this. Okay, and another thing, okay, this is like kind of a little bit of a shortcut observation. Okay, shortcut observation is that because you need to plot constant rate period later on in your r and x, r versus x. This is your constant. So to plot this constant, maybe you need to select 3 points or 2 points, 0.1, 0.2, 0.3. So those points normally in your x versus t, okay? So let's say this is your graph, and then this is your falling. So here could be your 0.1, could be 0.2, 0.3. So kalau you tengok 0.1, 2, and 3 here, if you plot, okay, if you plot the tangent for each point, okay, you take your ruler and then you draw a tangent there. So normally the point number 1, point number 2, point number 3, they are sharing the same dx over dt. So this is, you're going to plot the same value r here. Okay, the dx over dt value is the same because its slope is the same. So you're going to get a nice constant rate period up there. But when you have a point here, this one, the slope is changing. It's not the same. Okay, so the easiest way to observe where is the starting point and the end point of constant rate period is by, okay, if you have the x and t, and then you have this kind of graph pattern, take your ruler, put your ruler here, and trace this line, see where it's gonna go at the end. So this is gonna be the end. So this is gonna be like constant period. This is the normal, okay, observation. After this one, after the slope is changing, then it's falling. The dx over dt going to be changed, decreasing and decreasing. Okay, so this is things that you might need to take note so that you can produce a very nice rate of drying curve. Okay, once you know the rate of drying curve, now you're going to go to the calculation, of course. So how to calculate? For example, if because you know that you have constant rate period, another one is falling rate. So both involve different equation. So now we're gonna talk about the constant rate period sahaja. Kita akan tengok dekat constant rate. Constant rate kat mana? Kalau kita draw R versus X ni, you ada kat sini and then kat sini. So kita akan fokus kat sini. Dekat constant rate sahaja ini. Okay, what is the equation you can use? Okay, to calculate maybe time for drying, maybe rate of drying. So depends. Okay, what the area required, for example. Okay, so to calculate those time for drying or even the final moisture content, the area, so they have a few methods. Okay, first method, they use experimental drying curve ataupun experimental data, whereby you conduct drying experiment, you can obtain your apa ni x versus t, x versus t punya graph, and from here, how to find the total time? It's very simple. You know what is your initial x initial, what is the time here, time 1, and what is the x final? Go here. This is x t final. So total time is tf minus t initial. So you get total time of drying. It's very simple, this one. Okay, using the plot. But normally the question will be this one. Okay, using this one. And another one, if you have rate of drying curve. So how to find the time for drying? So rate of drying curve is where you have R versus X. Something like this. So now we are in this. We focus on this constant rate. All right. So how to get the time for drying if you have this kind of information? All right, it's very easy. So remember that the rate of drying is using this equation. This is general equation. R equal to minus Ls over A. Dx over dt. So you rearrange. Dt become over there. All right. So and then you integrate it. All right. So it become T equal to, well, integration of dt equal to Ls over A. Integration of dx over R. All right, because R is moving down there. So you have integration of dt. So T will become, since R is constant, R here is constant. So what happened? So R you can pull out. Okay, so it become here. Ls over A, you put C here as a constant rate period. And you integrate the dx, so it become x1 minus x2. From x1, let's say this is your x1 until x2, wherever x2, as long as it's still at the constant rate period. And the x2, the maximum is going to be xc. It cannot be exceeding xc, because when you pass xc, it's already at falling rate. Falling rate use other equation. Okay, you have to remember this. So this x2, maximum it can go is until xc. Okay, the turning point, the critical point. So how to use this one? Very simple. Okay, very simple. So if you have this data R dengan X ni, you tahu berapa nilai, you know what is the value of R here, RC, and then you just put the RC here, the value. Knowing your area, knowing your dry solid weight, and knowing what is your initial moisture content, and until what moisture content that you want to remove, then you can know the time. But this is time at constant. Okay, the time here you get is for at the constant rate period. Only at the constant, because now we are focusing on the constant rate period. Ada soalan? Soalan tak ada Okay, so it's again, let me try to derive it. R equal to minus Ls over A dx over dt. So it's a very simple punya arrangement. So dt is equal to minus Ls over A dx over R, because you are bringing down there. So now you integratekan t, alright, and minus Ls over A, integratekan dx over R. So now R is constant, pull out there. So since R is constant, you put notation as RC to differentiate R constant and R falling later on. Integrate of dx. So that's why finally you get T equal to Ls over A RC x1 minus x2. Okay, so you know the R value, then you can just put it, you know the area, you know the Ls, then you can get the time for drying at the constant rate period. Okay, ada soalan? Tak ada, simple kan? So this is simple. And there's a case that you don't have any data, any experimental data. Okay, you tak ada experimental data pun. There's a case. Now, sometimes, okay, you not even run experiment, but they're asking you, can you predict what is the time for drying or rate of drying? Then you can use what we call it here, method using predicted transfer coefficient. This one is we take account of mass transfer, mass and heat transfer. All right. So because you know that drying, you're giving heat to the wet solid, and then wet solid get the moisture get energy and then vaporize. Okay, remove as water removes as vapor. So that you're gonna have like heat transfer. The heat give energy, and then the mass is removed, the water removed from the system. So I'm gonna talk about this later on. Okay, for constant rate period. Constant rate period kita ada equation. Without running any experimental data, we still can calculate it. Okay, only at the constant rate period. Okay, now I try to move on to falling rate. Okay, sebab I want to complete the calculation. Okay, the experimental data. If you have experimental data in the constant rate, what you can do, okay, the equation that you can use is T equal to something, or you have like X versus X, or R versus X versus T, ataupun R versus X. So that is the method. They have a method to solve it. And the falling rate juga pun, kalau if you have experimental data, how do you want to solve it? Okay, problem. For example, you want to find the rate of drying, you want to find the time for drying, and so on. So saya akan pergi ni dulu. Sebelum I go back to constant rate menggunakan transfer coefficient, heat transfer ataupun mass transfer, heat transfer or mass transfer coefficient. Okay, that one involve derivation. You need to derive the equation involving mass transfer and heat transfer. Finally, you get equation, then you can use it. All right. So for falling rate, okay, kita dah tengok this is R versus X. So this is the constant. Constant kita dah tengok satu, if you have X versus T data, or secondly you have R versus X data. Okay, this is involve experiment. So dekat falling ni pun ada juga, if you have experimental data, so how you want to solve it. Okay. Okay, so for in the falling rate, so what happened is that, okay, they come back to this same equation. Okay, general equation R equal to minus LS over A dx over dt. You integratekan balik juga. dt equal to minus LS over A dx over R. Okay, so T, sorry. So you T dt here is equal to minus LS over A integration of dx over R. In the constant rate period, since R is constant, then you can pull out. But now, in the falling rate, okay, remember that kalau kat falling rate, kat sini, alright, this is constant, this is falling, this is R. So if you take any value here, for example, this one, the R value is not the same from one point to another point. Let's say this is 0.4, 0.5, 0.6. You see the R is changing, it's not the same. So it's not constant. So if it's not constant, you need to integrate it together, dx over R. Okay, so to find time, all right, from whatever x you want, so it's going to be like minus ls ls over A, ls over A, integration of dx over R. Okay, so this is the equation if you want to find the time. If you have experimental data, if you have like this one, you have plot of rate of drying curve. Okay, this is your plot of rate drying curve. Kalau you ada plot x versus t, so the plot is like this. It's the same method whereby falling tu kat mana? Let's say this is the falling, so this is xf falling, and then they want the final x is here, x final. So take t f here, and then this is t final. So total time kat falling, total time falling is going to be t final minus tf lah. Okay, untuk this one, this case. This is for x and t is very simple. Alright, but for R versus X is different. So this is the region that we want to find. Alright, so basically this one, to find the time here, so you can use this, you use to this equation ls over A, ls of course you know, A of course you know, but the problem is integration, dx over R. So this is the problem, the real problem normally. Okay, so for if you get the integration of dx over R, kalau you ada graph, so is meaning that is area is also equal to area below the curve. Okay, this one is back to your numerical methods. Okay, you learn about numerical methods, you learn about the Simpson rules, you learn about the few methods of integration, right? A few methods of numerical method to find the area below the curve or below the graph, right? So here, what graph need to have? Okay, if you look carefully, this is dx over R. So this is basically a graph between 1 over R versus X. Okay, you need to have a graph between 1 over R versus X because this one is 1 over R. Yang R kat bawah ni, di numerator, so it become 1 over R versus X. So you cannot just take this graph, X and R versus X, because this is not 1 over R, this is R. Okay, so you need to find a data of 1 over R versus X. X you already know, but now 1 over R. So how to get the 1 over R? Okay, so from here, you take R value. R, let's say this is R6, this is R7, this is R8, and so on. So you plot dalam table you R, R6, R7, R8, R9, and then you inverse it 1 over R. 1 over R6, 1 over R7, 1 over R8, 1 over R9. This point must be at falling period. Point yang you select ni semua dekat falling. Dekat constant tak jadi. Okay, cannot work. It doesn't work at constant. It's only work at falling. So once you get 1 over R, then you plot. Okay, bila you plot, you akan dapat, it's expected that your graph gonna be okay, this is 1 over R versus X. So your graph something, I think it's something like this. Okay, something like this. Okay, 1 over R versus X. All right, so what happened is that you need to find the area. Let's say this is the X, X6, this is X9. So you need to find the area here. Okay, need to find this area. So this area, once you get it, so you can just insert it here as a dx over r. Ada example dalam ni. Oh, tak ada. So this is how lah to get the integration of dx over r. I think you can look into your textbook. Okay, you boleh tengok textbook example. I can't remember what is the example of 9 something on the graphical method. Okay, graphical method untuk falling rate. Let me check. You is supposed to be example. You boleh go through. You can look now in your textbook. So example, because I need to go through a little bit on it so that you can understand why they are using that kind of table. Okay, example 9. Example 971. Okay, kalau you tengok example 971 tu, they ask you to find, they use the graphical integration dekat falling rate period. Okay, dalam falling rate period, so blah 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 and so on, dia ada data semua. And then what happened is that they plot, they build up a graph 1 over R, X dengan R, so dia dah boleh plot. Ini dekat falling sahaja, ni all dekat falling point, and then they find 1 over R kat sini. Oh, sorry. Oh yo. Delete dulu. Okay, we draw again. So you build up, you need to build up table for sure. This is to make things easy so that you don't miss anything. So you're the X, you're the R. So what happened? You plot 1 over R. So mana nak dapat apa ni R tu? So kita back to you punya graph R versus X kat sini. Okay, so this is your falling. Okay, from this falling, so you take the point lah. You take the point. For example, you take, okay, this is 1 point. I will put it like point R6. Okay, you pick another one, R7, for example, R8, R9, until your X final here. What is your X final? The one that being asked. All right. So let's say this is R10. So you just put it here lah. Value R6, R7, R8, R9, R10, and then you inverse it, all of them. Once you inverse, then you can plot graph of 1 over R versus X. So this one normally you're gonna get like, okay, this is gonna be a X6, X10, let's say. Right, X6, X10. So it's gonna be like something like here. Okay, this one, and then you want to find a graph, an area here. So this normally X6, this is normally X10, right? So now you want to find the area. So apa dia buat dalam you punya example tu? They show you one of the method from numerical method lah. One of the numerical methods. Simplest punya method. So apa dia buat? In numerical method, normally you gonna have to slice, okay, to get the area here, to get area below the curve, you need to slice it into a few pieces, right? Your apa ni area, the total area tu you kena slice. Right? Bila you slice, you akan tengok dia, and then you gonna assume that it's gonna have like to a nearest shape, easiest shape to calculate. In this case, they assume that this is like rectangle. Okay, something like rectangle here. So kalau kata you ada sampai sini, so you akan ada rectangle area 1, area 2, area 3, area 4, area 5, area 6. So berapa banyak you nak kena slice? If you have more slices, the area punya calculation will be more accurate. Tu je, simple je. Kalau you have 2 slices, normally it's not accurate. The area could be more than 20% or 30%. But if you have more slices here, for example, you have 1, 2, 3, 4, 5, 6 slices, maybe the area is going to be less than 5%. Okay, so now it become rectangle. So kalau you ada rectangle ni, okay, just imagine rectangle untuk dapatkan to get the area is basically width time dengan height je. Alright, so you need to know what is the width, what is the height. So this probably is okay. So dalam you punya text tu, dia ada buat the extend table tu. The extend the table, it become mana? Ada tak table? Oh, dia ni version lain. Okay, tak apa. So dia akan ada 1 over R average, kalau saya lupa lah. 1 over R average, lepas tu ada delta X. And then from there, you get delta 1 over R average times delta X. So this is you get area. This is area 1. This is area 2. And then you summation all the area. So kenapa dia pakai 1 over R average? Okay, just imagine this is R. 1 over R. This is also 1 over R. Because this rectangle is basically consisting of one height is highest compared to another side. Okay, this is the shorter side, this is the higher side. So what happened? They take average. So that's why you have average height here. Alright? And why is delta X? Basically this, to find the width. Delta X is basically this side minus this side. Okay, the right side minus left side, so you get the delta X here. So delta X times the height, you get the area A, one area. So then you do the same for the rest. So that's why in your textbook they are doing something like this. Okay, and then you get the total area. So this total area is basically equal to integration of dx over r. So whereby you can just put it away straight away to the equation t equal to ls over a. So this is equal to times the summation of area tadi yang sini. Alright, it's the same. Okay, ada question on this particular example? So you need to go through to this example so that you can understand why they are using, okay, why they are multiplying those things, because they definitely they want to find the area using the numerical method. Ada soalan? Okay, sorry, yang ni dia tak ada apa ni exercise dalam kelas for this one, because what you can do is you can just use the same graph that you already plot last week, okay, for rate of drawing, and try to find, just play around with it. For example, I want to find the falling from 0.2 until 0.05, for example, and then you try to use the graphical method, apply this thing, find the area of dx over dr. Then that is going to be like a practice for you. All right. All right. So then that is on the falling. Okay, on falling. Okay, that kalau kata you ada R versus X punya curve. Okay, dalam falling, so I have to finish little bit here on falling dulu. Lepas tu saya pergi dekat constant rate untuk yang apply heat transfer dengan mass transfer. Okay, I hope that you're gonna be okay because it's something like forward, backwards little bit. So but backwards is only on part of constant rate using the equation. How to establish the equation first. Okay, in falling rate, falling rate dia ada juga case. Okay, remember that you ada R, X, what we call it special case. This is constant. So dekat falling there are two special case whereby the falling rate is not curve. Curve ni non-linear lah. But it's rather than linear. They could be linear, something like this. Okay, this linear, they pass origin. Pass origin meaning that they pass the x0 and 0 coordinate. Okay. And then there's another case, okay, whereby falling, they also this linear, but this time they are crossing the y-axis. Oh my God. Okay. Straight line. Something like this. All right. Crossing the y-axis here. Okay, they have two case. Okay, dia boleh jadi dekat falling tu, you cannot see clearly dia punya curve, but it's rather than straight line, linear. Kita panggil linear lah. Alright. So this is linear. Linear special case. So kalau happen to be like this special case, okay, basically dia ada straight away dia punya equation. Don't worry, dia terus ada equation dia. So this equation tak perlu pun you ingat pasal the text, the exam going to be open book, right? So it's already in your textbook. Okay, this is for special case 1, whereby it's linear and pass the y-axis. Okay, pass the y-axis. So this is kita panggil case 1 lah. This one case 1. This one origin case 2. For case 1, to get the time for drying, you straight away can use this equation. LS over A dia dah derive sebenarnya. Dia from R equal to minus LS over A dx over dt, and then they put all the equation of linear there in the falling. Okay, and then they just moving around, and then you get this final equation lah. So LS over A, x1 minus x2. So basically x1 ni, they start from critical point from xc. But you have to remember this is only for falling rate. Falling rate kat sini je. So this is the xc. So they must start from here. Okay, they cannot from initial. So the region must be at the falling sahaja. So this is x. The most is xc minus x2 is the final moisture content divided by A R1 minus R2. So R1 going to be the R kat sini lah. Okay, depending on the xc ni. Minus R2 is the final. And ln R1 minus R2. So this one you boleh tengok daripada graph. Kalau you ada graph, you boleh tengok R nilai dia berapa. All the R value and the X, then you just put in and then you get the time. Okay, the second case, whereby is through the origin. The true origin, they have two. You can use this equation depending on the info that you have. For example, here LS XC divided by A RC ln RC divided by R2. Okay, so there's a case that normally you kadang-kadang, okay, you not even have a graph for this one. You tak ada graph pun, no graph. Tapi you boleh pakai lagi equation ni. When they mention about the true origin, you still can use it dengan menggunakan satu lagi. Use this another equation because this one you have just need to know the RC, final, XC, and of course the rest is the area and also the dry mass. So that is normal for any drying problem, you need to know what is the dry mass and also the area. So that information you already have. But the other information, for example, XC, RC, X2 is normally the one that been provided. It's easy to get compared to R2. R2 ni normally dia bagi ataupun you need to have to get it from the graph. Okay. So that's why they have two alternatives. You can use this one or you have to use this one. Okay, another one LS XC divided by ARC ln XC divided by X2. So you get the time. Okay, the time if it's falling itu adalah linear. The falling is linear and pass through the origin. So this one, right? Linear and pass through origin. It's going to be, in this case, the equation is T equal to LS over A XC C over RC ln XC divided by X2. Okay. Okay, so this is the equation. So for this one, case number one, the equation going to be a little bit longer. LS X, the most is XC minus X2 divided by A, RC minus R2 ln R1 divided by R2. Okay. So ni untuk equation dekat atas untuk case 1. Okay. So that is for falling yang melibatkan involve special case. Okay. So sekarang ni kalau falling you dah ada, you have known about three methods. One is finding the area below the curve involving dx over r punya graph. Secondly is you have special case whereby is a linear y-axis and or linear through origin. Okay, that's number 3. And in the falling also, okay, remember tak? I hope you still remember last week I mentioned in the falling there are two mechanisms involved in falling. One is diffusion, another one is capillary flow, depending on the type of material that you want to dry. If a paste-like type is going to be diffusion mechanism. If it's have a porous, so it's going to be the capillary flow. So for both mechanism, they have their own equation. All right. Example, for by diffusion. So this is very straightforward. Normally, kalau problem melibatkan falling, and they mention that the falling mechanism following the diffusion. For example, following the diffusion mechanism in the falling rate period. So straight away you can use this equation to find the time and also to find the rate. Okay, the rate is of course changing depending of the position of the x. All right. So the time is 4. So this is basically thickness. Small s here is a thickness divided by pi squared dl, diffusivity. Okay, this is diffusivity. Ln 8x1 divided by pi square x. So this is x1 is basically normally start at xc lah. So x here is x final, right? So for okay, because you have capital X and small x. Okay, this is capital X lah untuk moisture content. Alright, untuk small x here, x1 there is the thickness. Okay, for this thickness, this one you have to remember, if your material, for example, is suspended and is exposed to both sides, okay, top and below, both sides are exposed to the hot air supply. So what happened to the x? This x value you have to divide by 2. Because of why? Because the diffusion is basically going into two directions. In the middle going up and then in the middle going down. So that's why the thickness now become half. You have to divide by 2. Okay. In the case that only on the top surface exposed to the hot air ataupun bottom surface. Only one side that exposed. So you have to take all the thickness value as your x1. Right? So that is you need to take care of this definition. Okay, to find the rate of rate at falling ls, so this is basically ls over a dx over dt is pi square ls dl divided by 4. This is the thickness, is the same principle need to be applied. Area and x is the x final. Okay, or x whatever that you want to find. For example, x7, x8 or x9, they will correspond to their rate of drying using the diffusion mechanism. And for capillary flow, this is like you have like pore there, so the water can masuk and then vaporize. So you straight away can use this equation. So there's no derivation for it. Of course, there's a derivation, but I will not go detail about the derivation. So this is more application. So time is equal to x1 rho s, the density of solid, the latent heat at wet bulb temperature. Latent heat. Xc is the critical divided by H is basically the heat transfer coefficient. This is the same thing that we're going to come across later on in the constant rate period using heat transfer and mass transfer, right? T minus TW, so ln Xc divided by X. So this is X final to get the time. So this is the time to get the time at the falling rate period following the capillary flow mechanism. Okay, this X, the thickness, gonna apply the same principle. Okay, if it's both sides, so the X you need to divide by 2, the thickness. If it's only one side, so you can use the total X, the thickness that being used. All right. Okay, ada soalan? Polling kita dah habis. Basically, so to summarize is in falling. Sorry, I go back. Okay. Tadi apa yang kita dah pergi, what we already discussed is kita ada constant rate period, and you have another one kat sini. Falling rate period. Okay. So apa yang kita dah pergi tengok calculation satu is involve experimental data. You have data whereby your data is you have X versus T. Okay, there's free moisture content versus time dulu. Itu yang basic yang normally you gonna have. Okay. Can have X versus T. Here also you can have experimental data X versus T, right? The simplest way, okay, to find and fastest way to find the time for drying if you have this information. Secondly, you have R versus X, rate of drying curve. Ini pun sama, the R versus X. So from R versus X here, you may use equation of T equal to Ls over A R C x1 minus x2. Okay, this is the equation that you can use. For falling, T equal to Ls over A integration of dx over R. So you need to find the area here. Area of 1 over R versus X punya graph. Right? Then you can use this one. Okay, third, and then okay, the constant we hold because we have another method whereby they use the transfer, what we call it, transfer coefficient. Okay, this involve heat plus mass transfer. Ni kejap lagi kita akan pergi. We will discuss later on. Okay, and then falling rate, you ada method. The number 3 method is special case. Okay, special case. One case is basically y-axis, linear y-axis. Another case is linear origin. Ini dari equation dia. Right, in the falling rate period juga, kita ada lagi, we have number 4, the mechanism, diffusion. So you have their own equation. And then lastly, you have capillary flow, mechanism. So dekat falling, so this is all that you should know, okay? Should know how to solve maybe problem that related in the falling rate period, okay? So this is the only method. So maknanya kalau kata soalan keluar, okay, any problem, soalan dalam test ke final and so on. So this is the summary, which one that you need to use it depending on the question lah. What is the information that they give you and so on. Okay, dalam falling ni we don't have any equation involve heat and mass transfer. Tak ada, don't have. Only dekat constant sahaja. Alright, constant je you boleh pakai heat and mass transfer. So the rest ini kita dah pergi, and then kita tinggal yang ni, the last one, the last part. But last part ni before kita dapat derive, kita dah derive and so on, so they have a few parameters yang kita akan go back to the previous previous slide. That I will explain to you a little bit about the parameters. Okay, yang ada lah parameters yang ada. Okay, setakat sini. Until now, are you okay? Are you with me? Are you confused? Or you still blank? Or you want to ask something? Please.
Doktor,
Yeah, please.
untuk diffusion dengan capillary tu, kita guna bila situation tu bagi tahu dia punya falling rate period dia macam mana ke? Macam mana bila nak guna dua benda?
They will mention about that. So normally they will mention, for example, assuming that the falling rate, the mechanism is following the capillary flow. Then you see that keyword, straight away you can go to the equation capillary flow. Okay, just simple as that.
Okay, Doktor.
Alright. So there's no trick that soalan pun takkan buat trick cakap didn't mention anything, do not mention anything, and finally the answer scheme is basically using diffusion. No, definitely they will say something about it little bit. Okay, a keyword saying that diffusion ke capillary flow, and then it's understood that okay, you can use that equation of diffusion or capillary flow that they mentioned. At the same time, they also need to give, for example, if involve diffusion, you need to know the diffusivity. So maybe the diffusivity information is given and so on, then it's easy for you to get to know that okay, this is diffusion straight away. But even though the diffusivity is not given, remember that your gene complex is complete with mass transfer and heat transfer subject. So you can still get the diffusivity value. You can go through, buka balik chapter mass transfer, diffusivity value, then you can still get it in your textbook. So that's why textbook, open textbook test ni dia boleh jadi maklumat dia tak supply, but it's not expected that the info is not there in the question, meaning that we need to supply. No, basically that info you can get it from your textbook. In the textbook is you can go through, not necessary to the chapter that we teach you. It could be other parameters that might be linked. To solve it, you need to know this. That one is basically is from other chapter. So you can just, take it from there. Alright. Ada lagi soalan? Tak ada. Alright. Okay, kalau tak ada, kita akan pergi kepada ni. Basically, we're gonna go to the constant rate lah. This is the one that kita left behind. Kita tinggal dulu. I just purposely buat dia last kali. Okay, sebab dalam summary, in this summary that I given here, so kita dekat constant tinggal ni je, transfer coefficient. Alright, tinggal tu. Yang lain semua dah. The way that you solve it is that one lah. This is fundamental. Nanti you akan ada application. So application dia ada slightly little bit different equation depending on type of equipment that you use. Alright, for the heat transfer or mass transfer, the constant rate period, predicted transfer coefficient. So how to establish the equation? Okay, this is the scenario lah basically. Okay, I padam di sini. Okay. So let's say this is your wet solid, and then you expose to air with certain temperature, humidity, and maybe certain moisture content that still carry on in your air. So here, remember that you have water there, all right? So and then you have like film, water film layer that build up on that top surface. So then this hot air carry with them a Q, energy. Okay, the Q, the heat. So the heat is giving in to the surface on the water film. So what happened is that, okay, so the water receive energy and then is move away, vaporize, escape from the surface. So what happened is a flux of water that moving out from the system. So if I can zoom into this particular area, for example, so that diagram is basically become like this lah. Okay, it's become like this. You have moisture, you have Q that supply, the gas is supplying, temperature, humidity, and the fraction. The Q that giving in, okay, the heat that giving in to the water. So just imagine this is the water film, okay, just water film. And then enough energy, the mass is moving. What's mass? Mass of water become flux. So here on this surface, we can measure what we call it. This is the water fraction, okay, on that surface. This is the temperature at wet bulb temperature, and this is the humidity at wet bulb temperature. Humidity at wet bulb. Okay. So later on, we're going to see what is that wet bulb and so on. So first we derive the equation. So here you have, let me denote again, this is Y, the moisture. So this is the temperature at wet bulb, and this is humidity at wet bulb. Okay, so I explain why it's going to be a wet bulb. So for Q, okay, initially for this particular case, because the air is coming only air, when air in contact with the water film, so the air is basically a medium based on heat transfer. The air in contact with liquid, air, the gas with liquid, so it's going to be like what is the heat transfer type? It's going to be convection. Okay. So in this case, kalau kita tengok benda ni, kita akan ambil just only convection. Okay, kita pergi small dulu. Okay, kita pergi small, whereby we only consider convection. Because it's from air in contact with water film. Later on, once you understand convection, then you need to add on Nanti kena ada add on ni yang lain-lain, ada radiation, conduction sekali dalam heat transfer, in heat transfer. You can establish another equation for that. So that one is later. So now we focus on convection dulu. Okay, small piece dulu supaya you faham dulu, you understand. Okay, so for convection, for Q, the heat for convection, saya rasa semua orang tahu because you already took the heat transfer, right? Heat transfer coefficient by convection, so I put it sebagai C lah, QC AC. Right, because nanti kita ada conduction dengan convection, kita boleh terus letak notation yang berbeza. Okay, the heat, the Q is equal to HC area T minus T here minus TW. So this is the driving force lah. Okay, untuk heat transfer, the driving force is temperature different. Alright, so this is the energy, the Q. Okay, the heat for heat transfer of convection. So this one yang heat transfer coefficient ya. So ni semua orang dah tahulah apa benda. Okay, and then you ada juga flux. Flux ni because they get energy and mass. Remember that this transfer coefficient involve mass and heat together. Okay, you need to take into account both. Alright, when heat giving and then the water will be flux or going away as a vapor. So flux is equal to Ky, the mass division, and then the Y minus W. Sorry, the concentration different. Alright, so this is mass transfer. So this is the flux. Alright, so then normally the fraction, okay, Y fraction is difficult to measure. Alright, so difficult. So you need to change the Y here to become H, enthalpy. So enthalpy is easy. Oh, no, sorry, not enthalpy, humidity. So to humidity, they have a relationship between both. So basically the relationship is Y here is more or less approximate equal to humidity MB molar mass of air bagi molar mass of water. Okay, MB over MA. So you just replace it here. So what happened? The NA is become KY MB over MA. So HW minus H. Basically, you replace both and then you just take out MB over MA here. They are sharing the same. Alright. And for mass transfer, okay, mass transfer, you also can find the Q, okay, the heat, okay, equivalent to mass transfer. So the Q for mass transfer is equal to M A N A flux latent heat times area. Okay, so now you replace this one to this equation because you need to equalize. Okay, later on you need to equalize the heat by convection is equal to heat of mass transfer. They must be the same when they are reaching equilibrium. Okay, heat due to mass transfer and heat due to convection must be the same finally. So here when you replace it here, so it's become MA, and A is basically KY MB MA HW minus H latent heat area. Okay, so this one you can cancel out. So now Q become mass transfer become KY MB HW minus H latent heat times area. So you equalizekan both convection dengan mass transfer, so it become HCA So Q equal to HCA T minus TW equal to KYMB latent heat area HW minus H. Alright. So in this case, we want to remove the A and also the latent heat there. So it becomes everything divided by A and latent heat. So it's become now Q over A latent heat equal to HC. A is cancelled over latent heat T minus TW equal to KYMB HW minus H. Okay. So to find the constant rate RC, okay, RC is basically equal to this equation, Q over A latent heat wet bulb. Tadi you dah derive kan kat sini. So this is equal to RC lah. Q equal to A latent heat wet bulb. So it depends on the info that you get. Kalau kata info tu involve heat transfer coefficient, then you can get RC, you can use equation RC equal to HC over latent heat T minus TW. So this is one equation. Involve heat transfer. This is equation 1. Nak dapat RC. RC juga, you can get RC from mass transfer. So RC equal to KY MB HW minus H. So this is the second equation. Okay, the second equation. So RC also you can get it from heat mass transfer and also from heat transfer. Or if you know the value of Q, you know the area, you know the latent heat, then you can also get this RC. So meaning that you can have three equations. Okay, to find RC, this is involve heat transfer 1, this is mass transfer 2, and this is another one 3 if you know the Q. Right, the Q of the heat being given, area and latent heat, then you can get the RC. Why is important to get RC? Okay, remember that padam dulu sikit. Okay, dalam equation constant, yang you ada T equal to LS over A RC X1 minus X2. Remember this equation. Ni kan ada equation sebelum ni. Kat mana saya summarize kat sini. You ada R versus X ni kan. So here, because you know the RC, this is the RC that you get it. And then you can just replace it here to get the time at constant, okay, menggunakan that RC there. Okay, RC value here. So this RC you can replace. Katalah, let's say I replace dengan heat transfer. So RC is equal to HC latent heat T minus T, so T minus TW. So it will become RC here, so you're going to HC latent heat, T minus TW X1 minus X2. Right, so this is how to find the time kalau menggunakan heat transfer. So you just transfer the RC tu, value dia. So dia jadi kat sini lah. So dia jadi kat sini. So this is a full equation yang dah replace RC. Or kalau you replace, this is heat. So untuk mass, so this is the one that they replace untuk mass. KY MB HB minus H. Then you can find the time. You boleh calculate the time. Okay. So this is basically coefficient untuk dapat R dulu. Untuk dapat constant rate. Once you get the constant rate, then you insert in the equation of this one. You dah dapat ni, you masuk. Sebab you tak ada graph. Okay, just imagine this time you don't have graph of R versus X. If you have graph, you can just get the RC value from the graph. But in this particular case, you don't have graph. So then you need to find the RC value. Once you get the RC, then you can calculate the time. And then that time is involved in the constant rate period. Okay, so if you remember that RC is equal to, kalau involve heat transfer, you ada HC divided by A, SC, okay. Latent heat T minus TW. So here is heat transfer coefficient. So the heat transfer coefficient here, kita ada in your particular, in your textbook, they already introduced what we call it a simplify punya methods untuk calculate H tu. Tapi ada dua case. They have two case. One case is air flowing parallel to the drying surface. Macam mana? Ni you punya solid. So air flowing macam ni. Parallel. So you can use this one. This formula. Case 2, air flowing perpendicular. Kalau air is subjected to the wet solid, something like perpendicular like this, then you can use this equation. Okay. In this particular equation, you need to know the G. So G is the mass velocity. Okay. So the range, and then they have a limitation. Why they have? What is the limitation? You can use this equation if you comply with this one. Temperature 45 to 150. The mass velocity 2450. Okay. And the air velocity 0.61 until 7.6. So that if you comply, then you can use this one, right? And for air flowing perpendicular to the surface, so this is condition, the G value and the V value. V is velocity lah, air velocity that coming. And then you can use this one. So apa you kena buat first? Normally the question gonna mention like, for example, our air is supplied parallel to the surface and so on, or air coming like 90 degrees Celsius from the surface. Then you know that, oh, this is perpendicular, or this is parallel. And from there, you know that, oh, okay, you can use this equation straight away, but you need to confirm first the value of G, temperature is within the range or not, and the velocity is in that range or not, right? Before you can fully utilize to get the H. Okay, boleh? Soalan? Okay. Tak ada soalan kot sebab 11:44 ni, sebab tak ada soalan. Semua dah sibuk nak memasak untuk buka agak ni. Okay, now okay, sebelum saya pergi ke what is the H, the TW and so on, kita tengok example ni. Tengok yang mana yang kita boleh calculate dulu. Ini example dalam you punya textbook 963. Okay. So let's say dia ada granular material, they want to dry dalam pan tu 0.4 times 0.4 times 25.4 mm deep. Okay, in the case of drying, normally the deep is not play any role, except the depth ni dia guna untuk falling. Kalau falling dia kena tahu thickness. But in the constant rate, normally you kena tahu dia punya area sahaja. Okay, even though dia bagi sampai 3 dimension, but you need to know the area. Area from here times here. Okay, not time depth. Depth you could time semua, you akan dapat volume. Alright, so the material is 25.4 mm depth in the pan, and the side and bottom can be considered to be insulated. So it's something like, kalau you ada letak dalam pan, like that. Okay, so side dia, kiri kanan ni semua insulated. Insulated maknanya tak ada heat pun boleh masuk in and keluar. So dia put dia punya granular material semua kat sini. Okay, so dia ada size lah, size dia 0.4, tinggi ni 25 5.4 mm. Okay. So heat transfer is by convection. Dalam kes ni dia beritahu heat transfer by convection. Even if they never mention about the heat transfer by what and what, you need to assume. Okay, kalau dia tak boleh tahu semua radiation semua kena consider, then you just assume convection saja. Alright. And the air stream flowing parallel. Okay, air stream flowing parallel to the surface ada velocity. So velocity dia bagi. Velocity is 6.1. Air temperature dia adalah 65.6. Humidity is basically 0.01. Okay, estimate the rate of drying for the constant rate period. So dia suruh cari rate of drying. Kalau you tengok ni, if you look at the question, say, oh, tak ada data ni. Even tak ada data experiment, you still can calculate it using the equation yang involve heat transfer and mass transfer coefficient. Okay, so here they mention about humidity. Okay, humidity kita tak pergi lagi. Apa tu humidity? Okay, now kita akan pergilah. Okay, kita akan pergi some of the parameters yang you need to know. Okay, this one. Okay, vapor pressure. First, we start with vapor pressure of water. Okay, vapor pressure of water ni is basically water punya vapor pressure. So whereby you can get it from steam table. Okay, data dia. So the vapor pressure is the changing, okay, between pressure and also temperature. If you have phase diagram, for example, of water, you ada liquid, you ada, this is liquid, you ada solid, and you ada a gas stream. So how the phase change depending on the temperature, also the vapor pressure. So this one is basically plot. You can ada plot ataupun table dekat you punya appendix. Dalam appendix you ada, dia produce as a steam table. Kalau you tengok you punya steam table tu dia ada, if you look into your steam table, appendix A2 you ada temperature, lepas tu you ada pressure. So this is corresponding to the vapor pressure. Okay, that pressure is vapor pressure. Kalau you tengok temperature 100, vapor pressure is, kalau ATM is 1 ATM lah. Alright, 1 ATM, ataupun kalau dalam tu 14 PSI ke, ataupun 101.325 kilopascal. Okay, you tengok sama, 100 degree, you tengok boiling point of water is 100 degree, so the vapor pressure is 1 ATM. Okay, so if you have more different pressure, so the temperature akan lain, change accordingly. So that is the vapor pressure. So why is important to know this one? Nanti ada equation yang akan pakai nilai vapor pressure ni. So that's why they introduce this one. Okay, humidity. This is very important. Okay, what is humidity? Humidification and dehumidification. This one is basically you learn in the unit operation, so I will not touch on that. So we go to this humidity. So humidity is, if you look here, is the kg of water vapor contained in 1 kilo of dry air. Okay, let's say this is container. So this container consists of dry air. Let's say ada 1 kilo. 1 kilo dry air dalam container ni. Let's say lah. And you have the H2O, water vapor moving around. Okay, kalau you boleh tangkap, you can capture that water vapor and then you timbang dia. Then you boleh dapat, boleh tahu timbang dia, boleh tahu berapa mass dia. When you know the mass, then that gonna give your humidity value. Artinya mass of H2O, berapa dia punya kilo H2O over 1 kilo of dry air. Dalam dry air tu berapa banyak yang ada water. Okay, water vapor tu banyak ada dalam 1 kilo dry air. So that is, we call it humidity. Okay, that's why kalau if you imagine that ada some people say Western country the humidity is low. Humidity is low meaning that dia punya water vapor dalam air dia sikit. Okay, kalau kita in Malaysia, our humidity is high. Because of kita punya water vapor dalam air kita banyak. Okay, but before that, you ada 1 kilo of dry air kan kat sini. Okay, dalam air, okay, this is air. Let's say this is container and then it contain of air. So dalam air ni basically ada dua benda. Dalam air, in the air, like the air that you breathe, you're breathing now, we don't talk about the oxygen, carbon dioxide and so on, but this is in the perspective of drying. In air consists of, they have two components. One is dry air plus water vapor. So ada dua komponen yang build up air. Okay, contoh you kat bilik you sekarang in your room, so you fill the air. So that air is basically consists of dry air and water vapor. You have to remember this. Okay, the component of air is basically dry air plus water vapor in context of drying. Tak cakap pasal oxygen and so on lah kan. Okay, so by equation you boleh pakai ni lah. To find humidity is equal to 18 divided by 29. 18 is molecular weight of water, 29 is molecular weight of air, taking from nitrogen lah. And this is partial pressure of that condition. Maknanya you tahu air tu condition dia apa, minus partial pressure of water. This one normally is given. Kalau tak given, susah you nak guna equation untuk dapat humidity. Okay. So there's another thing, what we call it saturated air. Apa tu saturated air? Okay, kita pergi balik dekat sini. Dekat container ni you ada 1 kilo of dry air. Lepas tu dalam ni ada water vapor. So in 1 kilo of dry air, basically, dia ada maximum limit. They have a maximum limit of water vapor that can be contained in that 1 kilo. Okay, let's say I put more water here. So water tu akan masuk dalam ni. Okay, dia akan naik-naik lah dia punya mass. At one stage, sampai satu stage, when you add water here, water cannot enter anymore. They bounce back. Because the water is already saturated. Reaching saturated at 1 kilo of dry air, the mass of water vapor is already saturated. So when it reaches that saturated, we call it saturated air. Okay, air which the water vapor in equilibrium with the liquid water at given temperature and pressure. Okay, so the vapor pressure, ingat kat sini ada tadi vapor pressure, P small PA, is basically equal to vapor pressure. Now you ada guna the vapor pressure ni. Pada saturated air, partial pressure equal to vapor pressure. Mana dapat vapor pressure? Where you can get vapor pressure? From steam table. So to calculate the saturation humidity, when you are saturated air condition, you can calculate the saturation humidity. Okay, so saturation humidity is 18 divided by 29. PAS is basically vapor pressure, P minus vapor pressure. So this one you can get from steam table. Macam mana nak tahu mana nilai dia? You tengoklah dia bagi air tu condition dia berapa, temperature dia berapa, temperature pressure. So from temperature tu, you go to the steam table, you see that this they're gonna give you a pressure. That is vapor pressure. Alright? Then you can calculate the HS. Okay? And then you can calculate percentage humidity. Percentage humidity as H divided by HS. Maknanya H ni yang tak saturated, non-saturated, divide by saturated. So you get the HP. Right? And then this is the equation lah. Dia just masuk balik. Equation kat sini dengan equation ni dia play around. Another things is the relative humidity. Percentage humidity HR. So HR is basically partial pressure divided by vapor pressure. Yang ni you kena tahulah. Partial pressure. Baru you boleh calculate HR. Kalau HP je, just enough humidity dengan saturated humidity. So you just divide by 2 times by 100. You get the percentage. Okay. So, yeah, I think I have to finish this one first and then we're going to stop. Okay, dew point. Okay, dew point is very, very simple. I think you all pun dah tahu dah, come across with it. Dew point is the temperature at which the water vapor become liquid. Ni macam pagi-pagi lah. Early in the morning, you can see that they have mist. on the surface of leaf. Kalau kat daun tu ada dia punya macam, dia panggil embun. So this dew point is titik embun. What is the temperature that you creating that embun? So this is, we call it dew point. The temperature at which a given air and water vapor would be saturated. Bila dia jadi saturated, okay, remember air ni, when you reaching saturated condition, water vapor tu tendency dia akan jadi liquid sangat tinggi, very high. To become liquid very high bila dalam keadaan saturated, because all of them are full, the dry air full with water vapor, banyak sangat water vapor. So that water vapor tend to become condensed and become liquid. So the temperature that become condensed, we call it dew point. Okay, and we can calculate the heat. Okay, the air, dry air punya ataupun air punya heat, we call it humid heat. Kalau dalam solid ke liquid kita panggil heat capacity, tapi dalam air kita panggil humid heat. So humid heat is basically amount of heat required to raise the temperature of 1 kilo of dry air plus water vapor. Remember here, kilo of dry air plus water vapor. Meaning dry air plus water vapor, dia jadi air, air lah. Okay, tadi saya dah cakap air is equal to dry air plus water vapor. So this is the total. So berapa banyak energy required untuk raise up temperature of this air? 1 degree Celsius. So equation is CS 1.005 times plus 1.8 humidity. So you need to know the humidity. Then you can get the CS value. So that is the humid heat. And then you have humid volume. You boleh juga calculate the air punya volume. But we don't call it volume, but we rather call it humid volume. So use this equation. In this equation, you need to know the humidity and everything here, 2.8 plus this one, times the temperature in Kelvin. And then you get the volume. And then you can also calculate the enthalpy. Okay, enthalpy of the mixture, air-water mixture, because you need it in the energy balance later on. Alright, so using equation of, they use the symbol of HY. Okay, this is different with the, you also have the HW, right? H at wet bulb temperature. Okay, and then this is the HY, enthalpy. So this equation, 1.05 plus 1.8 humidity, temperature minus T reference plus latent heat reference times humidity. Okay, example here, you take 0 degrees Celsius as reference. So what happened to this equation? T minus 0 plus latent heat here at 0 degrees Celsius is basically 2501 times humidity. So in this case, you need to know, or you need to recap how to find the latent heat, because it's very important in drawing. You're going to always use it. Kalau you salah method, salah lah jawapannya nanti. Alright, so this case dia select as a 0 degree Celsius lah, as a T reference. So you boleh select any reference. Katalah you want to choose 20, then you jadi 20 lah, 20, and then this is 20, and latent heat here is at 20 degrees Celsius. So what is the value? To find the enthalpy. Okay, so kita tengok example ni. Macam mana nak kira humidity? You ada room, let's say this is your room. Okay, this room, temperature here adalah 26.7, pressure here is 101.325. Okay, partial pressure 2.7 kilopascal. Okay, so calculate humidity. Okay, humidity is equal to 18 divided by 29, partial pressure divided by pressure minus partial pressure. Okay, so dalam case ni you dah ada nilai dia. Partial pressure is 2.7, pressure is 101.3 minus 2.7, so you get the humidity. Okay, HS is 18 by 29, partial vapor pressure divided by pressure minus vapor pressure. So vapor pressure mana dapat? You pergi tengok dekat steam table 26.7, what is the vapor pressure? So masukkan nilai dia and dapatkan nilai HS. So HP adalah H divided by HS times 100. Kita dapatlah HP. HR is basically 100 partial pressure divided by vapor pressure. So you bagilah. So you done. It's not that difficult. Okay, on top of humidity ni, kita pakai equation. Kita juga boleh menggunakan what we call it humidity chart to get the humidity. This one next week, I will show you how. Okay, to use this one. To find one value to another value. Because this one, you're gonna use this, yang tadi, yang constant rate involve heat transfer and mass transfer. Most of them gonna use there lah. Sebab tu saya bawa pergi kat sini. Okay, soalan? Okay, kalau tak ada soalan, so then I think I just end the lecture until this slide. Okay, so then next week we're going to continue. I hope that you're going to read through some part of the material, because I think humidity chart, and then they have a adiabatic and so on, so you can read through first, and then next week I have to discuss with you what is that, how to use it. At least when you read through at the beginning, so when I explain it, you're gonna get a better understanding of it. All right, so then I think that's all for today. So thank you very much for your attention today. So see you next week. I think next week is gonna be your test, right? Betul tak?
Yes, sir.
On Wednesday. Right?
Yes,
so the test is going to cover only absorption and crystallization. Okay, so do your revision because you have plenty of time now. All right, so thank you very much. So see you next week. Assalamualaikum.
Thank you, Doctor.
Thank you.
Thank you, Doctor.